Solutions of a linear equation. As we have discussed about the graphical understanding of a linear equation to be a straight line in a graph paper, let's see how the solutions also which can be identified or understood equally through the graphical concept. Graphical understanding of solutions of a linear equation is the topic of the session. As we have seen that the solutions are the values which satisfy the given linear equation. So let's see what values satisfy the given linear equation. Let's take the same problem as discussed in the previous session, that is the example problem. (4x plus 2y minus 8 equal to 0). And equally, this equation was identified with the linear equation y to be this, cutting the x-axis at 2 and cutting the y-axis at 4 as discussed in the previous session. Now the similar example taken is a straight line with this equation. Now let's see how we can understand the solutions of this linear equation. Now as we know that linear solutions are the values which satisfy the given linear equation. It is the values of x and y in this Cartesian plane which satisfy the given line. That is, when I take for example a point out here which is 1, what is its respective y coordinate? When x is 1, clearly we identified in the previous session that y is 2. So I got this to be when x is 1, y is 2. Therefore, this coordinate is 1, 2. This is A and this is C. So let's see how we can find the solutions. So one of the solution which is identified to be B is with x equals 1 and y equals 2. So one of the solution is x equals 1 and y equal to 2. Now imagine how many such points exist on the line. As we can see this line, there are infinitely many points which lie on this line, implies there are infinitely many values of x and y on this line which satisfy the given line. That is, there are infinitely many values of x and y in this Cartesian plane which satisfy this linear equation, indirectly the line in the graph. Therefore, the line in the graph clearly proves because of the infinitely many points which makes the line, there are infinitely many solutions for the given linear equation. So graphically, it proves since a line is formed by infinitely many points x comma y, infinitely many points x comma y, therefore its respective linear equation, as in this case being this, has infinitely many solutions, is how I understand the infinitely many solutions connected with the given line. So a line has infinitely many points through which the line is created. Therefore, its respective linear equation has infinitely many solutions x and y belonging to R. Graphical understanding of solutions of a straight line. Learning outcome, infinitely many solutions. Now that we have discussed about the linear equations in graphical concept as a straight line in the xy coordinate system, let's see the different special cases of the straight lines. That is, the special cases of the linear equation in its own special case as a graph. Initially, I would like to know what kind of straight lines pass through origin. So the question here is, if I want to identify a linear equation which passes through origin, what would be its respective linear equation? Is how we are going to investigate in today's session. So this first special case is line through origin. A straight line is said to pass through origin if it has its constant 0. So let's see in brief about a line through origin. For example, I have x-axis and y-axis. So I wanted to just identify a line which passes through origin. Passing through origin. So when a line passes through origin, what would be its equation? How does the linear equation look like? So in this case, a linear equation would be in the form y equals kx. That's how I understand. A line passing through origin has its linear equation in the form y is equal to kx. A line passing through origin always has its linear equation in the form y is equal to kx, or it can also be written in the form p of xy ax plus by equal to 0, is how I understand a linear equation passing through origin. The learning outcome out here is that when a line or a linear equation passes through origin in the xy coordinate system, its constant value vanishes. Therefore, if I have the general linear equation ax plus by plus c equal to 0, this constant vanishes when it passes through origin. Therefore, a line which passes through origin would be in the form ax plus by equal to 0, with ab belonging to real numbers and ab both non-zero, is how I understand the special case of a line passing through origin, which can be expressed in the form y is equal to kx or ax plus by equal to 0. Ax plus by equal to 0 with the conditions ab being real numbers and ab both non-zero. Let's see an example problem in the continued session. For example, when I want to identify a line passing through origin, if suppose I have y equals 2x, then clearly this is in the form ax plus by. So in order to identify whether this line is passing through origin or not passing through origin, I first try to reduce this into the general form. With the condition a line passing through origin must have the condition ax plus by equals 0. Therefore, y equals 2x implies this can be written as 2x equals y, and therefore this y when brought to the left is written as 2x minus y equal to 0. Clearly, as I see the comparison, this can be written in the form ax plus by equals 0, which says that since the constant value is 0, since 2x minus y equal to 0 does not have a constant value, therefore this must pass through origin, is how we conclude. Since this does not have a constant value, therefore 2x minus y equal to 0 passes through origin. It should be a line which passes through the origin in the xy coordinate system. A straight line passing through origin represented by ax plus by equal to 0. See, the constant vanishes is how I understand. Now that we have seen the linear polynomial y is equal to kx, which has its own graphical properties passing through origin. Now let's see one example problem to understand the concept more stronger. Imagine I have a line y is equal to 3x, or I take y is equal to 2x. And my question out here is to sketch y is equal to 2x on the Cartesian plane. So let's see how this linear equation in two variables x and y with its special case looks in the Cartesian plane. Now, as we know that the given equation is y is equal to 2x, where the constant c is missing, it's clearly in the form y is equal to ax plus b, where b is 0. I mean ax plus c or ax plus b, where the constant is 0. Therefore, this line must pass through origin in the form y equals kx. So this line passes through origin is how I understand the concept of the given example problem y equals 2x, a linear equation in two variables x and y without the constant as a special case. Now, in order that I sketch this, the first thing which I take into the rule is about the table of values. Now, as we know that to sketch the line or to make a line, it is minimum of the 2 points which are required. So, if I have 2 points which can be identified for this line, which lie on this line, then it's easy to sketch the line. The minimum conditions for a line are 2 points. My first row with variable x and my second row with variable y. When x is 0, my y is also 0, because when x is 0, my y is 2 times of x, which is 2 times 0, and this is 0. Therefore, when x is 0, the y coordinate substitutes to get the value 0. Similarly, if I take another value, say 2, when x is 2, my y is 2 times of x, that is 2 times of this 2, which is 4. Therefore, when x is 2, my y is 4, is how I understand the sketching concept through the table of values. Now that for 2 points I have got one of the point as represented by the second column and the other point represented by the third column, I clearly understand that there are 2 points P which is 0, 0 and the points Q which is 2, 4. That is, the points P 0, 0, that is the origin, and the point Q which is 2, 4 pass through the given line y equals 2x. So let's see how we can sketch utilizing these two coordinates as evaluated through the table of values. Now that we have evaluated the values of P and Q which lie on the line y equals 2x, let's see how we can sketch the line utilizing these two coordinates on the Cartesian plane. So initially I'm going to start with sketching of the Cartesian plane with x-axis and y-axis. The horizontal axis, which is x-axis, and the vertical axis, which is y-axis, and the point of intersection, which is the origin. Clearly, let me first make a scale of 1 centimeter equals 1 unit on x-axis. So here is 1, here's 2, here's 3, here's 4, 5, 6, and etc. so on and so forth. And on the left, I have -1, -2, -3, and -4. Similarly, I take a scale of 1 centimeter equal to 1 unit even on the vertical axis, that is the y-axis. 1, 2, 3, 4, 5, and similarly the values on the negative side of the y-axis being -1, -2, -3, -4, and so on and so forth. So with this scale of 1 centimeter equals 1 unit on x-axis and equally the 1 centimeter equal to 1 unit also on the y-axis, let's see how we can sketch the points. Starting with point P. The point P is origin, that is the initial point 0, 0. Therefore, I see that this point clearly is the origin which is fixed here. So my point P is out here. Coming to the next point, point Q is 2, 4. That is, the point moves 2 units to the right from the initial point, 2 units to the right from initial point, and 4 units up from there. Therefore, once I reach 2 units to the right from its initial position, I jump 4 units to the top. Is how I get the point Q, which is 2, 4. Is how we get the point Q and point P in the Cartesian plane. Now, as we know that to draw the line, minimum 2 points are essential. Now that we have got the points P and Q in the Cartesian plane, it's about sketching the line. Sketching the line is about joining the 2 points and extending the line on the either side. So here I just join P and Q and extend in this manner. So I get this to be a line which is extended on the either side and equally passing through P and passing through Q. Both the points as obtained through the line y equal to 2x. Therefore, the line as obtained passing through P and Q clearly is witnessed to have been passing through origin. So what do we make the learning outcome? The biggest outcome here is that if the line y equal to 2x is expressed in the form y equal to kx, then that line must pass through origin. Therefore, a line y equal to 2x with the points 0, 0 and 2, 4 as picked and on random choice are just located on the Cartesian plane here and here, And when a ruler is taken and you draw a line, it passes through P and Q, and we obtain this line. And this line, as it is represented by the arrows, is nothing but the line y equals 2x. And importantly, this line expressed in the form y equal to kx passes through origin. It must pass through origin because it does not have a constant. No constant must pass through origin. A constant, then the line does not pass through origin. So a constant plays a vital role in deciding whether the line passes through origin or does not pass through origin. Y equals 2x passes through origin is the learning outcome in this problem. A, y equals ax plus b does not pass through origin if b is not equal to 0. The condition is this line does not pass through origin if b is not equal to 0. If b is equal to 0, then this reduces to the form y equal to kx or y equal to bx, and the line must surely pass through the origin. B, the constant, decides the factor for the line passing through origin and not passing through origin, as seen through the example problem y equal to 2x. Now that we have taken the case of y equal to kx, which passes through origin, as a special case, let's get into the next special case in case of the linear equations in two variables x and y. In this case being x and y. So let's see the case number 2 in the topic of the session. Now before we start with this, let's try to analyze what happens if the line is parallel to x-axis. There are chances of lines not always passing through origin or not passing through origin, but different cases where a line is exactly parallel to x-axis or a line is parallel exactly to y-axis. So let's go into investigating the cases of lines parallel to x-axis and parallel to y-axis accordingly. Line parallel to x-axis. So let's take the first case of a line parallel to x-axis. What would be the equation of a line parallel to x-axis is what is the investigation in the session, today's session. Let me take a Cartesian plane to investigate a line parallel to x-axis and its respective form. So I take the x-axis and the y-axis and the origin. Now let me take a line which is exactly parallel to x-axis. Parallel in the sense any line I draw along the parallel to x-axis in the sense it is at equal distances at every pair of points. That is, when I take a line say I take the line this, which is assumed to be parallel to x-axis. Now this is parallel only when each of the distance as taken, the perpendicular distance between any 2 points on the two lines are equal. So imagine I take this distance and this distance. If they are equal, then I say the lines are parallel. Equally at distances, equally at equal distances. It cannot have unequal distance at any stage of its parallelity, is how we understand parallel lines. Therefore, let me say the line L is parallel to x-axis. the line L is parallel to x-axis. This is the representation for parallel. So line L is parallel to x-axis. So let's see what would be its equation and its investigation. Imagine I have this line which cuts y-axis at k. So imagine that this line cuts y-axis at exactly the distance of k units. This is how I understand the distance of the line from x-axis to be k units. Now let's see what would be the equation of line. Now let me just take randomly any point out here. Say for example, I take the point P which cuts y-axis. P is the point where the line cuts x-axis. The line cuts y-axis. Point where L cuts y-axis. Therefore, the coordinates of P, because this is the y-intercept, simply because it cuts the y-axis, the line cuts the y-axis at the point P, P must be the y-intercept. If a line cuts x-axis, then that point will be the x-intercept. If the line cuts y-axis, then that point of intersection is called y-intercept. So P is the point where the line L cuts y-axis, as clearly seen out here in the diagram. Point where L cuts y-axis, which is 0, k, because the distance from O to P is k units, as can be seen clearly in this diagram. So this being k units, I have this to be 0, k is how we get the coordinates. Next, let me take the general form of the line, the general form of line L, which we know is represented in the form ax plus b. Or ax plus by plus c equal to 0 is how we get the general form. So let me take the general form ax plus by plus c equal to 0, where the condition, we know that a, b, c are real numbers and a and b are not equal to 0, is how we have discussed about the general equation of a line or linear equation in two variables x and y, which can be represented in its general form as ax plus by plus c equal to 0. Now since this line passes through the point P, the coordinates of the point P must satisfy the given equation, is how we understand the representation of the line through the point 0, k. Therefore, P lies on L. Since P0k lies on line L, therefore this must satisfy the line L. Therefore, P satisfies line L. That is, the coordinates of the point P satisfy the line L. Let's see how we are going to satisfy the line through the coordinates. Now let's see the formula. What is the condition for the line L parallel to x-axis? So here comes the formula. Any line L, this line may be anywhere in the Cartesian plane, provided the condition that this line is parallel to x-axis. So any line L which is parallel to x-axis, here being the line L. So any line L which is parallel to x-axis is of the form y equal to k, is how I understand the formula, where k is the y-intercept, or k is the distance from the origin to the line L, or the distance of the point on x-axis, or the distance between the line L and x-axis. Therefore, any line parallel to x-axis must be of the form y equals k, k being the y-intercept, the point where the line cuts y-axis, the y-intercept. So this is how we derive the formula, where any line parallel to x-axis is of the form y equals k, understood through the formula. Now let's see an example problem to identify the line which is parallel to x-axis through the given formula. Now let's see an example problem to understand the concept more better. The question here, which says, find the equation of the line which is parallel to x-axis and at a distance of 3 units below x-axis. Now here I have a question which has the various conditions taken into account. For example, the question here is, find the equation of the line which is parallel to x-axis and which is at a distance of 3 units below x-axis. So let's see how we can identify the line through the given conditions. So before we do this problem, we need to analyze the given conditions through the Cartesian plane. Without the Cartesian plane and the display of this information on the Cartesian plane, it is impossible that we can solve this problem or any mathematical problem. Display the information in the Cartesian plane is the demanded condition out here. So let's see how we can convert this into the Cartesian plane. The Cartesian plane, which consists of x-axis and y-axis intersecting at origin, x dash and y dash intersecting at origin. Now the question says we had to find the equation of the line which is parallel to x-axis. The condition which we have seen in the previous session is about that any line which is parallel to x-axis is of the form y equals k. What's k? K is the y-intercept, or the distance of k is the distance between the x-axis and the line, the perpendicular distance. So let's see which is the line which we need to find is said to be parallel to x-axis and at a distance of 3 units below x-axis. Now since the line is 3 units below x-axis, I obviously take the line below the x-axis. So as we take the scale, 1, 2, 3, 4, 5 and 6, and then I have my scale here, -1, -2, -4, and then I have 1, 2, 3, 4, -1. is how we get the scale taken as 1 centimeter equal to 1 unit. Now since the line is 3 units below x-axis and exactly parallel to x-axis, it moves 3 units down, and I have a line which is out here. Which is like this. So here is the line which is parallel to x-axis and at a distance of 3 units from x-axis is how we understand below x-axis. Now, in order that we find the line, we know that any line which is parallel to x-axis, say this is the line L. So L parallel to x-axis implies y is equal to, the line L can be expressed in the form y equals k, because any line parallel to x-axis is of the form y equals k. So this can be expressed as y equal to k, and k is the y-intercept. My k out here is the y-intercept. Now as I know my y-intercept out here is minus 3, therefore k is minus 3. As clearly seen, my line cuts y-axis at negative 3. So my value of y-intercept, that is k, is minus 3. Therefore, substituting k equal to minus 3 into this form, I get this to be y equals minus 3. Therefore, the equation which I demand for is y equals minus 3. Therefore, for the given question, the equation of the line which is parallel to x-axis and at a distance of 3 units below x-axis, with a distance of 3 units which is below x-axis, is y equals minus 3. Is how I conclude with the line parallel to x-axis. Now that we have taken the condition of a line parallel to x-axis, the next question which arises is about what is the situation when a line is parallel to y-axis. So today's investigation in the session is about a line parallel to y-axis. What would be the formula if the line is parallel to y-axis? Let's start this with the Cartesian plane. The Cartesian plane, which is x, y, x, x dash and y, y dash, intersecting at origin and then let's take a line which is parallel to y-axis. Say for example, I have a line this is the line L which is parallel to y-axis. Now let's see what will be equation of this line L. Imagine this line cuts x-axis at k, just like the same line cutting y-axis at k when it is parallel to x-axis. Similarly, if the line is parallel to y-axis, it must cut x-axis, but it never cuts y-axis. So it cuts x-axis at say k. Now the question comes, what would be the equation of this line L? So let's see how we can just derive for this formula. Any line L which is parallel to y-axis and cuts x-axis at k that is the distance from origin to k is k units, is how I understand the other way. So geometrically, this distance is k units, that is the distance of the line from y-axis is k units, is how I understand the concept. So any line L which is parallel to y-axis and cuts x-axis at k, in this case the line being L dash, that line is of the form x equals k, is how I understand the formula. Any line parallel to y-axis and passing through k, cutting x-axis at k, that is when the x-intercept is k, then the equation of the line L is of the form x equals k. Line parallel to x-axis, y equal to k. Line parallel to x-axis, line parallel to x-axis, y equal to k. Line parallel to y-axis, x equal to k, is how I understand the concept. Let's see an example problem to understand the concept more stronger. Let's take an example problem in which I need to find the equation of the line parallel to y-axis, the special case of linear equations in two variables x and y. Imagine I have an example problem which says find the equation of the line which is parallel to y-axis and makes an intercept and makes an intercept 3/2 units. So here I have a question with its respective information which I'm going to convert into the Cartesian plane, and through the Cartesian plane I can find the equation of line accordingly through the respective formula. So let's see how I can display the information as given in the question into the Cartesian plane. The question is about finding the equation of the line with the condition that it is parallel to y-axis and makes an intercept 3/2 units. So let's see how it makes an intercept. So as I take the Cartesian plane with x and y-axis intersecting at origin, let me just take it with a scale of 1 centimeter equal to 1 unit on x-axis and 1 centimeter equal to 1 unit on y-axis. This is -3, -4, and so on and so forth. And the scale on y-axis is 1, 2, 3, 4, and then -1, -2, -3, and so on and so forth. Now clearly it says the line is parallel to y-axis and it cuts and it passes through the intercept 3/2 units. So initially it is very essential that we locate the x-intercept, which is 3/2 units. Now here is 3/2 units is the x-intercept indirectly 3/2 units is 1.5 units, is how I understand the x-intercept. So using the condition of x-intercept being 1.5 units, let's see how we can draw a line passing through x-intercept and parallel to y-axis. As we know that the value 1.5 units is clearly located at in between exactly the middle of 1 and 2, this is the x-intercept. And of course, the line passes through this point exactly in the middle of 1 and 2 and parallel to y-axis, is how the question is analyzed through the Cartesian plane. So let's draw a line parallel to y-axis and passing through the x-intercept 1.5 units. This is the line, L dash is the line which passes through the x-intercept. L is parallel to y-axis and L passes through x-intercept equals 1.5 units. Therefore, the line L passes through the x-intercept, which is 1.5 units. So let's use the formula. Now comes the importance of the formula. As we have seen in the previous session that any line parallel to y-axis and passing through k units being the x-intercept is x equal to k, and therefore my x-intercept, which is k, is identified to be 1.5 units, and therefore line L dash is given by x equal to k, that implies x equals 1.5. So the equation of the line which is parallel to y-axis and passing through the x-intercept of 3/2 units, which is 1.5, is given by x equals 1.5. Is how we identify the equation of a line parallel to x-axis and parallel to y-axis as the special cases. The special case of linear equation in two variable x and y, line parallel to x-axis and line parallel to y-axis. Now comes the question on the linear equation which can be sketched on the Cartesian plane. What if the line is given on the Cartesian plane and I would like to find its equation? I am talking about the reverse process of understanding the line and its graph. So let's see the investigation in today's session about how we can identify the equation of the line which is on the Cartesian plane. The reverse process of understanding the line through the graph. So let's see the concept. The reverse process here is, given the line in Cartesian plane, finding its equation is how we are going to identify through this. So let's see how we can identify the line through its, identify the equation of the line through its line in the Cartesian plane. Let's see how we can investigate. For example, I take the line which is in the Cartesian plane to investigate through its equation, which needs to be identified through the plane and its line. So let me take the Cartesian plane x dash and y dash. Now let me take the scale on x-axis, which is 1, 2, 3, 4, 5, 6, minus 2, minus 3, and this and then along y-axis, which is 1, 2, 3, and this. Now let me take a line on this Cartesian plane. Imagine I take a line with this, and so on and so forth out here. So I get the line passing through say this. Here is the line. Here is the Cartesian plane. Now my question is, what will be the equation of this line? Is how I understand the reverse process of understanding that given the line in Cartesian plane, how to find its equation. So let's see how we can find the equation of this line L. Now here I have a Cartesian plane in which the line lies here. As clearly this passes through origin, the first thing I identify that this line L must have the equation y equals kx, no doubt, because it passes through origin. It must be of the form y equals kx. And similarly, as I see that every x coordinate, when x is 2, I identify its y as 1, which I identify. Now when x is 4, I see that my y is 2. Similarly, when I take the third point, when x is 6, my y is 3. So I try to identify a pattern between the x values and the y values. So clearly I see here that 1 is always, when I write this in the form 2 by 2. Similarly, when I have y equal to 2, indirectly it is nothing but 4 by 2. So this 4 coming into the numerator. Similarly, when I have y equal to 3, which is obtained from the third point, it is nothing but in terms of x, which is 6 by 2, provided this gets connected with this. Clearly we see that in this, every y value is half of the x value. That implies every y value on L is half of its x value, as clearly seen in this investigation, which shows every y value on line L is half of its x value. Therefore, my every y mathematically is half of x, is how I identify. Therefore, I got an equation which is y equals x by 2. Therefore, equation of line L is y equals x by 2, is how I understand. Equation of line can be identified through its line in the graph. This line in the graph in the Cartesian plane is with its equation y equal to x by 2, investigated through its x coordinates and y coordinates, which gives me the condition. Reverse process of understanding the equation of line through its Cartesian graph. Now that we have discussed about linear equations, in two variables x and y. Let's try to apply in real life and see the application of a line in real life situations. There are many situations which demand for linear equation, like speed, velocity, all are related to the linear equation. Velocity time graph is a linear equation, etc. So let's see more of real life applications of linear equation through one of the real life situation. Now, as we have seen that in lower classes we have learned the conversion of centigrade to Fahrenheit, the temperature conversion which you have learned about centigrade to Fahrenheit or Fahrenheit to centigrade is what we are going to see as a real life situation. For example, real life applications of a line or a linear equation. Let's see how we can apply this in real life situation. For example, I have temperature conversion equation. Usually we have the temperature conversion which is done through the mathematical calculated equation through the data collection, which is given to be F equals 9 by 5 C plus 32. Temperature conversion equation F equals 9 by 5 C plus 32 is what is the linear equation in x and y. So using this temperature conversion equation, F equal to this is used to calculate initially the Fahrenheit when C is 30 degrees, and secondly the centigrade when the Fahrenheit is 12 degrees. So let's see how these conversions can be done for the given real life situation. So I have in the initial case the centigrade degree which is given in the temperature of 30 degrees, through which I want to know its respective Fahrenheit temperature. So for this centigrade temperature, I would like to find the temperature in F, its conversion in Fahrenheit scale. So let's see how we can do that. The given conversion equation, the linear equation, is F equals 9 by 5 C plus 32, which is clearly in the form y equals ax plus b. Here F is assumed to be the y coordinate and C is assumed to be the x coordinate, where y equals 9 by 5x plus 32. That is, when I take the x-axis and the y-axis, this is Fahrenheit, this is centigrade which comes in x-axis, and the Fahrenheit which comes on y-axis, is how we understand graphically connected with C and F, C for x and F for y. The Fahrenheit is 9 by 5 plus C plus 32. My question 1 demands for finding F. To find F when C is 30 degrees. The value of C is 30 degrees, which when substituted in to the given problem, F equals 9 by 5 times of C plus 32. So the value of C as given in the question as 30 degrees substituted to be 9 by 5 times this plus this, which on further simplification gives us 5 ones 5 6, 6 nines 54 plus 32. 86. Therefore, my F is 86 degrees Fahrenheit. So 30 degrees centigrade converts to 86 degrees Fahrenheit out here. Is how we understand the conversions which can be done given the linear equation y equals ax plus b, y for F and x for C. Next, let's see the next problem about finding C when F is 12 using the same linear equation. Secondly, my second part is about finding C. So to find C, let's see how we can find the centigrade temperature for the Fahrenheit. F is given to be 12 degrees Fahrenheit. That implies when I substitute into the given equation, 12 is 9 by 5 times C plus 32. So when F is 12 degrees Fahrenheit, I convert by substituting to F equals 12 and then simplifying to find C. Now it's about finding C, so I take this to the left hand side. 9 by 5 C plus 32 is 12. That implies 9 by 5 times C is 12 minus 32. 32 comes to the right as minus 32. That implies 9 by 5 C is 12 minus 32 is minus 20. And then which on cross multiplication gives us 9C is 5 times minus 20, which on further simplification gives us 9C is minus 100. That implies C is negative 100 by 9, which approximately converts to minus of 9 ones 9 and then 10, 9 ones 9 and then 10, 1, 1. So approximately C is negative 11.1 degrees Fahrenheit. Is how we understand the conversions as done through the Fahrenheit. So F equals 12 implies C equals negative 11.1 is how we can find the values of the temperature conversions using the linear equation. My next question here would be, when will the two temperatures be equal? Is there any possibility to find when the centigrade and Fahrenheit scale reach to the same value? So let's see if we can identify the temperature at the break-even point. That is, at the point where the two temperatures C and F are equal. So let's continue with the continued question out here. So my next question out here is, when will the two temperatures F and C, when will the two temperatures on F and C scale meet is my question out here. So when do they be equal? Let's see if we can find that point where F and C are equal. In order that we do this problem, it is very simple that we assume that the two temperature scales are equal and then find the value, a reverse process of working out. So assuming that f equals c, let's try to find the value utilizing, of course, the linear equation, real life applications of a line. Now that f equals c, I substitute f equals 9 by 5 of c, so my f being c replaced with c plus 32. So here my f gets replaced with c, is how I understand the substitution. Now let's find the value of c by taking all c terms to the left. So here I get this to be 9 by 5 times c plus 32 is equal to c, which on further simplification gives 9 by 5c minus c equals negative 32. 32 comes to the right as minus 32, c goes to the left as minus c. So taking the LCM, we get this, which on further simplification gives 4c by 5 is minus 32. That implies c is 4 ones, 4 eights, so minus 8 times 5. Therefore, c is minus 40, and f equals c implies is how I can identify the values of f and c being equal to 40. Therefore, when the temperature reaches 40 degrees centigrade or 40 degrees Fahrenheit, the two temperatures meet on the same scale. That is, (40 degrees centigrade is exactly equal to 40 degrees Fahrenheit. Only at 40 they both are said to be same. 40 degrees centigrade equals 40 degrees Fahrenheit is how I understand the applications of line in real life situations. Temperature conversions being one of the real life application. Let's reconsider the example problem f equals 9 by 5c plus 32. The temperature conversion formula in its linear form. If my question was to draw this, clearly this is a linear equation in two variables f and c. This is a linear equation in f and c. Therefore, this must be a straight line. Its graph is a straight line. That is, when I take this on x-axis and y-axis, my centigrade scale on x-axis and my Fahrenheit scale on this gives me a line with y-intercept cutting at 32, and my slope is positive, so it cuts x-intercept, x is 0, when yf is 0, I get minus 32 somewhere out here. So this is how I get the line when I sketch on the xy coordinate system or FC coordinate system. A line in its temperature conversion is a straight line in the Cartesian plane, as can be drawn using the table of values. Sketching a line for a real life situation.